Okay, y'all, let's cover the next section. Let's do 7.3. This is unit circle. It says evaluate exactly, no decimals. So we want the sine of 2 pi over 3. This is a radians version on your unit circle. It's a radians angle. So I'm just going to whip out the unit circle real quick, and we're going to look at 2 pi over 3. Now you need to remember that the sine of the angle is the y value of the coordinate. So here is 2 pi over 3, which means that this is the cosine version, cosine of the angle, and this is the sine of the angle. So the answer for 2 pi over 3 sine is square root of 3 over 2. No decimals. I will let you know when you can provide decimals on the exam. Cosine of 5 pi over 6, so 5 pi over 6 is right here on the unit circle. Again, the x value and the coordinate is your cosine, so your answer is negative square root of 3 over 2. And then last is tangent of 2 pi over 3. Well, tangent is equal to the sine of the angle over the cosine of the angle, so sine of 2 pi over 3 divided by the cosine of 2 pi over 3. And I just need to pull those together for you. Sine of 2 pi over 3 is square root of 3 over 2. And we're going to divide that by the cosine, and the cosine is negative 1/2. All right, so now we're going to keep, switch, and take the reciprocal or flip the last division. So it's square root of 3 over 2. Division becomes multiplication. And then we're going to take the reciprocal to 2 over 1 for the dividing of the fraction. Now, when you multiply, I can reduce these, and this becomes square root of 3 over 1 times negative 1 over 1. So square root of 3 times negative 1 is negative square root of 3, and these are just over 1. So there is my tangent for 2 pi over 3. All right, the next one is give the coordinates of the unit circle for the angle theta equaling 5 pi over 3. Now, do we have 5 pi over 3? We sure do. It is right here. So the coordinates are 1/2 and negative square root of 3 over 2. There's the coordinates. Next is determine the reference angle for 5 pi over 4. Okay. Here is 5 pi over 4. And we want the reference angle. So this is use my highlighter. This is referencing this terminal side here. So that means that this is 5 pi over 4. Okay, and we're looking for the reference angle. Now remember, the reference angle is the distance between your terminal side and the x-axis. So this angle here is going to be the reference angle. Now notice this is quadrant 1, 2, 3, and 4. We're in quadrant 3 for this terminal side. So to find the reference angle, you just take the absolute value of pi minus the angle. And this is for quadrants 2 and 3. Well, our angle is 5 pi over 4, so we're going to just subtract 5 pi over 4. Okay. Now, you have to know that there's just a 1 in front of this pi, so I can make this number 4 over 4 pi minus 5 pi over 4. 4 minus 5 is negative 1, so negative pi over 4. But the absolute value shows distance, so that removes the negative. Anything that comes outside of the absolute value becomes a positive, and our reference angle is pi over 4. The next one is negative 11 pi over 6. So we need to know where 11 pi over 6, negative 11 pi over 6 is. Well, here's 11 pi over 6, but it's not negative 11 pi over 6. But it's going to be the same distance. So if it took this distance to get to 11 pi over 6, going clockwise, it's going to take the same amount of time, and that's going to get us to this terminal side here. This would be our negative 11 pi over 6. Okay, so that's one way of viewing it. The other way of viewing it, well, that's so you can see that it's quadrant 1. All right, so if you start here and you go clockwise to negative 11 pi over 6, which is the same distance, then you're going to see that that angle from here to here, which is going to be your reference angle, is pi over 6. Next is determine the quadrant for 4 pi over 3. All right. So, oh, I don't think yeah, I have it right here. All right. So 4 pi over 3 is in quadrant 3. And that's a 3. 1, 2, 3. And then negative pi over 4, well, that would be going clockwise. Notice that pi over 4 is halfway between 0 and pi over 2. So it's going to be halfway between 0 and 3 pi over 2 because we're going to be going clockwise. So from here to here is going to be our negative pi over 4. And that means it's going to be living in quadrant 4. All right. If the cosine of theta is equal to negative square root of 3 over 2, okay, and theta is in quadrant 2, all right, find the sine, tangent, secant, cosecant, find the other 5 trig functions. Rationalize the denominator for your extra credit. Okay, so if we know that the cosine of angle is negative square root of 3 over 2, first of all, let me show you something. If you know that, that means that your angle is 150 degrees, right? Or you could use radians if you want, but I don't think you're going to want to do that. So we know that if this is our cosine, this is our sine. There you go. There's that. That's because this was given to you. So my sine of my angle, which is 150 degrees, is equal to 1/2. If you didn't know that, if you didn't have access to your unit circle, you do have access to the Pythagorean identity. Okay, so you could have used that. But in this case, it's so much simpler. Then we can find our tangent of theta, which is your sine of theta over cosine theta. Sine of theta is 1/2. Divide that by your cosine theta, negative square root of 3 over 2. Keep, switch, take the reciprocal, so 1/2 times negative 2 over the square root of 3. The 2's reduce. You're left with 1 times negative 1, which is negative 1, over 1 times square root of 3, which is square root of 3. Now, this is the correct answer. If you want to receive extra credit, you can rationalize your denominator by multiplying by the square root of 3 over the square root of 3. This gives you negative square root of 3 over 3. Let's look at secant, which is 1 over the cosine. So 1 divided by negative square root of 3 over 2. All right. Keep, switch, take the reciprocal. 1 times negative 2 over the square root of 3, which is negative 2 over the square root of 3. Again, rationalize your denominator if you want the extra credit. Oh, equals, that's an equal sign, sorry. Negative 2 square root of 3 over 3. Since square root of 3 times square root of 3 is square root of 9, square root of 9 is 3. Let's find the cosecant, which is 1 over the sine. All right, so that's 1 divided by 1/2 right there, which is 1 times 2 over 1, which is 2. We are living in quadrant 2, so only cosecant and sine are going to be positive. And then lastly is cotangent, which is cosine of theta over sine of theta. Cosine is negative square root of 3 over 2. Divide that by 1/2, which is your sine. Keep, switch, take the reciprocal. All right, 2's are gone. We're left with negative square root of 3. That is it for 7-3. We'll see you in the next one and the last one.